We are still in the section 1-2 talking about function continuity. In this particular section, we are going to be looking at increasing and decreasing functions. And what we have at the bottom of our notes here are pictures of a function that you would consider to be increasing, meaning that as we move along the x-axis, the function, the y value, is also increasing. So as x increases, y also increases. The function also overall is increasing. A decreasing function still looks as x is increasing, y, the function itself, is in a downward pattern. It is decreasing. So we're going to be looking at increasing functions, decreasing functions, and then we're going to see a third called a constant function. So if you flip your notes over, here we say, and we can define, an increasing function is one that as x increases, and I'm going to just shorthand using arrows, also then y is increasing. You could also say the function is increasing. A decreasing function is one that as x increases, meaning as you're moving along the x-axis from left to right, y, or the function itself, is decreasing, is going in a downward motion. A constant function still has, as x is increasing, y, on the other hand, does not change. Y stays the same. An example of that would be a horizontal line. And if you notice that all three of these have as x increases, all three has as x increases, meaning going from left to right, look at your change in your y value, which is your function. So as we go on a graph, we go from left to right along the x-axis, increasing from negative infinity to positive infinity. As we go from left to right along the x-axis, as x increases, what is the graph doing? Down here, we're going to look at a couple examples, fairly simple examples of increasing and decreasing functions. And we can see, if I just draw little hash marks at each point in which that graph is changing direction, I can see in this first interval that my graph is decreasing. The second interval, the graph then is going up. Third, I am decreasing, and then fourth, I'm ending with an increase. And if I want to represent these using interval notation, I can see that on the first interval, it is decreasing, and along the x-axis, that value would be -6. So it's decreasing from here to here. And so I record that along the x-axis. So that's -6, -3. Both of those points are solid circles, and so that therefore they are included. Therefore, I'm using brackets. The second interval, so I'll just label that as the first one. The second interval looks like it is increasing. It is going, again, along the x-axis from -3 to 0. Both of those are inclusive. That is the second interval. The third interval goes from 0 to, let's see, that looks like a +3. Again, that is inclusive, so I'm using brackets. And then I end in an upward motion from 3 to 6. And that would be my last and final interval. Again, representing increasing and decreasing using interval notations, brackets and parentheses. All of those were closed circles, therefore I have brackets in every one of those intervals. The one down below looks like a common parabola, but pay close attention to the ends of the parabola, not going on to infinity, but with open circles, meaning those points are not included. I have marked along the y-axis the point at which it changes direction. So it looks like the first interval I am decreasing, and that would be -4 along the x-axis, because as I go from left to right, this graph is going down in the downward motion. So I go from -4 to 0. That point lies right on the y-axis. There's not an obvious open circle there, so I'm going to have that included. And then I increase from 0 on up to 5. It ends with an open circle, so therefore I close that with a parenthesis, not a bracket. The last one on this page represents the graph x squared divided by x squared minus 1. And I look here, and I have looks like an infinitely discontinuous function. And so I have what I could label as 4 different sections, 4 different intervals in this graph. This would be the first, this would be the second, my third, and my fourth. So I'm going to represent each one of those using an interval notation. Therefore, I will have 4 different intervals that I will be classifying as either increasing or decreasing. And I keep in mind through all of this that I'm moving from left to right, not ignoring that fact. I don't start at the y and move backwards, or start at the origin and move backwards. I'm always going from left to right, understanding this is negative infinity and this is a positive infinity. So the first interval, I'm starting out here, and it looks like that it is moving in an upward rotation through the entire section. So that would be considered to be an increasing interval. And I represent that since that is coming from negative infinity, and it is approaching, and there is a vertical asymptote right here at -1. It is approaching -1, but never touching. So I represent that with a parenthesis. My second interval goes, now be very careful here. That second interval is very small. It is only occurring between -1 and 1, and it's just this leg of the graph right here. Now yes, it is approaching negative infinity from the y, but when I'm doing increasing and decreasing, I represent that in terms of x. So I look at this as I'm at -1, the graph is way down here. But as I approach 0, the graph is moving in an upward motion up to that origin. So I would consider that to be increasing because it's starting down here. As x is -1, it is starting down here and moving up till I get to the origin. That would be considered increasing. -1 is not included, as that is an asymptote right there at -1. We'll talk about that further in our notes. And it approaches 0. That point is absolute, and so I can make that inclusive. My third interval, I'll locate that as the first interval, the second interval. My third interval is from 0 to +1. Again, I have another asymptote at +1. And then as I'm moving along the x-axis, so it's just from 0 to 1 is this next interval. But as I go from 0, approaching 1, this graph is now making a downward, almost like a waterfall, downward motion, so that would be decreasing. So I'm going from 0 to 1. 1 is not included because that is an asymptote there. It will never touch that graph. It will gradually approach it, but never touch it. And then I end, again, from 1 on to infinity is my fourth interval. And I am starting, yes, up positive infinity along the y, but increasing and decreasing is not represented using the y. It is represented along the x-axis. So I'm starting at 1, and then as the x value gets greater and greater, the y value is getting smaller and smaller. So I represent that as decreasing. So I would say 1 to positive infinity, moving in that direction. Increasing and decreasing intervals, always represented along as x moves from negative infinity to infinity. It's always represented using the x value and using interval notation.